Those were some pictures on my duckweed experiment. The problem I had was that many species can't live in the same environment due to factors such as competition and parasitism. But some live better in that way, in the form of mutualism and commensalism. So which one was duckweed? My hypothesis was, I think the two duckweed species, Spirodella and Lemna, will grow faster and better in separate environments because of reduced competition and increased resources. But after the experiment, this was the data I had gathered. The duration of the experiment was 10 days. The Spirodella environment started with 5 individuals and reached 9. The Lemna environment started with 12 individuals and gradually grew to 19. Then came the mixed environment with both Spirodella and Lemna individuals. The mixed environment started off with a total of 12 individuals, 3 Spirodella and 9 Lemna. Soon it went all the way up to 23 total individuals. I decided to graph the growth. This is my legend. Spirodella in yellow, Lemna in blue, the total mixed number in green, and the other two in orange and purple. After graphing their growth, this was what I got. My x-axis was time in days, and my y-axis over here was the number of individuals. The Spirodella environment, marked yellow, grew from 5 to 9 individuals. The Lemna environment started from 12 and grew to 19 individuals. These two environments only had one species each, Spirodella and Lemna and Lemna. But the mixed one had both Spirodella and Lemna individuals, marked orange and purple. The total number of mixed individuals had a growth that looked like this, growing from 12 all the way to 23. Could tell the mixed environment's growth was faster and better compared to each species being put in separate environments. But to look closer, I compared the Spirodella individuals in the mixed environment and in the Spirodella only environment. Comparing the two, I could see that both of them were pretty much the same, except for the fact that one of them started at only 3 individuals and the other at 5. So there wasn't much of a difference with the Spirodella. But when I compared the lemna individual's growth from the two environments, there was a difference. With the mixed one in purple and the one with lemna only in blue, I could see that there was a spark between day 2 and day 5. The mixed environment had higher growth there. So I compared it to the total number of individuals from the mixed environment, and it looked pretty much the same. That and the fact that the lemna from the mixed environment started at a smaller number than the lemna from the lemna only environment told me that lemna had a higher growth rate in a mixed environment than in an environment with only the same species in it. On the other hand, Spirodella had pretty much the same type of growth rate in both cases. And that was my result. The two duckweed species grew faster and better in a mixed environment, unlike what I thought of my hypothesis. The Spirodella specimen didn't experience much of a difference in the two environments, but the lemna specimen did. They experienced faster and better growth in the mixed environments in the form of commensalism, where in this case, the lemna individuals benefited from it, and the Spirodella didn't really get affected by it. So my conclusion? Well, my conclusion is that the two duckweed species, Spirodella and lemna, grow faster and better in the same mixed environment, benefiting in the form of commensalism. That's why, as a solution, duckweed species could be grown in mixed environments to benefit and get optimum results. Solutions like these will help in things like fish farming, food production and consumption, biofuel, and many more. So, keep experimenting.